These are the top 10 new discoveries made by AI in space. Number 10. AI finds hidden planet-forming disks in archived space images. Let's start with something most people never think about. Not new planets, but the places where planets may still be forming. Using a neural network called Anomaly Match, astronomers scanned nearly 100 million image cutouts from the Hubble Legacy Archive in just 2 to 3 days. It returned about 1,400 anomalies, and after a review, around 1,300 were confirmed as real, with more than 800 never recorded before. Among them were planet-forming disks. And that's a big deal, because these disks are the raw material of future worlds. They show scientists where planets may be taking shape around young stars. So this wasn't just AI spotting random strange objects. It was helping uncover environments where entirely new solar systems could be forming. And right away, that tells you something powerful. AI is not just finding what already exists in space, it's also helping scientists spot where the next worlds may be born. Number 9. AI discovers hundreds of hidden cosmic anomalies. Now, this next one shows just how powerful AI becomes when you give it decades of archived images. Astronomers built a neural network called Anomaly Match and turned it loose on nearly 100 million image cutouts from the Hubble Legacy Archive. In just 2 to 3 days, it scanned the full data set and returned around 1,400 anomalies. After manual inspection, about 1,300 were confirmed as real anomalies, and more than 800 of them had never been recorded before. Think about that. Hubble has been observing the universe for decades. Some of the most iconic images in astronomy came from that telescope. And yet, even inside that archive, there were still hundreds of strange, rare, and previously unnoticed objects waiting to be found. Among them were merging galaxies, ring galaxies, planet-forming disks, 417 merging galaxies, and even 86 gravitational lenses. That means the discoveries were not hidden because they were impossible to capture. They were hidden because the archive was simply too huge for humans to fully sort through. AI changed that in days. Number 8. AI detects new fast radio burst signals. Now, let's move from images to signals, because this is where things get even more intense. First, fast radio bursts are some of the strangest events in space. They're powerful bursts of radio energy that appear and vanish in milliseconds. Miss the moment, and it's gone. That's why speed matters so much. Researchers working with the Breakthrough Listen initiative deployed a new AI system on NVIDIA Holoscan, and it was able to process fast radio burst data 600 times faster than previous methods and over 160 times faster than real time. At the same time, it improved detection accuracy by 7% and reduced false positives by a factor of 10. That is a massive leap. And over at Chime, machine learning systems have already helped detect about 4,000 fast radio bursts since observations began. One study even identified 66 repeater candidates, with 18 of them missed by earlier classifiers. So this is no longer just about seeing more of space. It's about catching events so brief and so rare that without AI, they might disappear before we even realize they happened. Number 7. AI discovers new gravitational lenses. Now, this is where AI starts helping us see the invisible. Using machine learning models on images from the DESI legacy imaging surveys, researchers uncovered about 1,210 new gravitational lenses, nearly doubling the number already known. And that matters a lot. A gravitational lens happens when a massive object bends the light from something behind it, almost like the universe making its own magnifying glass. When AI finds more of these lenses, scientists get a better way to trace hidden mass, especially dark matter, which we still can't see directly. So this isn't just a cool visual discovery. It gives astronomers a much bigger data set for studying the unseen structure structure of the universe. Number 6. AI identifies new asteroids and near-Earth objects. Now, let's bring this a little closer to home. The Asteroid Institute and the University of Washington developed an algorithm called Thor, which connected tiny points of light across huge telescope archives and recognized them as the same moving objects. That led to 27,500 new asteroid discoveries in 2024 alone, including more than 100 near-Earth objects. And that's a big deal, because a lot of these were found in archival data, including observations from telescopes like Pan-STARRS. The information was already there. AI just figured out how to connect it. And when those hidden objects turn out to be asteroids or near-Earth objects, the stakes become very real very fast. Number 5. AI reveals hidden galaxy collisions. Now, this one is a great example of how one AI system can unlock multiple discoveries at once. The same anomaly match project that found strange Hubble anomalies also revealed 417 merging and interacting galaxies hidden in the archive. And that matters more than it sounds. When galaxies collide, they can reshape entire systems, trigger intense star formation, and change how galaxies evolve over billions of years. So, by finding hundreds of these events in old data, AI is helping astronomers build a clearer picture of how the universe grew and changed over time. And if this many collisions were missed before, it makes you wonder how much more is still hiding in the archive. Number 4. AI detects new pulsars in deep space. Now, this one is just brutal in terms of scale. China's FAST telescope has been using machine learning methods to sift through enormous data streams. And by mid-2025, it had detected over 900 new pulsars. More than 650 of those came from the Galactic Plane Pulsar Snapshot Survey alone. What makes that even crazier is that this total was more than 3 times the pulsar tally discovered by all foreign telescopes during the same period. That gives you a sense of how powerful this combination really is. A pulsar is basically the ultra-dense remnant of a dead star, spinning fast and sending out beams of radiation like a lighthouse in space. But spotting them's hard. Their signals can be weak, noisy, and buried under mountains of radio data. So, this is exactly the kind of job AI was built for. It can scan signal after signal after signal without getting overwhelmed. And that means it can pull real discoveries out of what looks like chaos. Number 3. AI maps dark matter structures in the universe. Now, this is where things get really wild, because we're talking about something humans still can't directly see. Dark matter is one of the biggest mysteries in space. We know it exists because of gravity, but we can't actually photograph it. So, for years, scientists had to rely on massive simulations that used huge amounts of computing power. Then, AI stepped in. Berkeley's lab CosmoGAN project creates convergence maps that mimic dark matter distributions inferred from gravitational lensing. And the big breakthrough is that these AI-generated maps are statistically indistinguishable from full physics simulations. That matters because the older process could take billions of compute hours and petabytes of storage. AI makes that work far more practical, scalable, and accessible. Number 2. AI discovers new signals from black hole activity. Now, let's talk about one of the most intense things in the universe, black holes. They tear apart stars, bend space-time, and generate some of the most extreme signals we can detect. The problem is, a lot of those signals are buried inside massive amounts of X-ray, radio, and gravitational wave data. That's where AI changes the game in a